Hello, you're here because you need some homework help. So I'll be doing a few problems on the homework to help you out. So I opened up and I'm on the second page here where we're trying to find some limits. I'm going to be doing these problems 1, 3, and 5, and I want you to try the rest on your own for the homework. This homework will be a quiz grade, so I expect your best attempts on these. All right, number 1, let's talk about this, and I want to make sure you are able to see this. First thing is first. I realize that I can't take this limit, and I want to make sure there's no glare. Well, it's the problem that's written on your paper, but I realize that I cannot take this limit because when I plug in 7 for x, the top doesn't give me a problem. I have a problem here. Because if I plug in 7 here, I get 7 minus 7. That's going to give me 0 in my denominator. 0 in the denominator is not allowed in math. We can't have that. So that's why we got to use some algebra, manipulate this expression so that we are able to evaluate this. So this type of problem was near the beginning of the year when we learned about multiplying by the conjugate. We're going to be using multiplying by the conjugate. So for example, if I tell you a plus b and I ask you what is the conjugate of a plus b, the conjugate simply negates the sign. So instead of a plus, it's a minus. So a plus b, my conjugate is a minus b. That's just a refresher. That's what conjugate is. When you have square roots found in your limits, we usually use the technique of multiplying by the conjugate. And you'll see why in this example. Let me go ahead and erase. So we're going to be multiplying by the conjugate of the part of my expression that has the square root found in it. Because my square root is found in the numerator position, I'm going to be multiplying the top and bottom of this expression by the conjugate of that numerator part. So the conjugate of this, instead of a minus 3, it's going to be plus 3. So I'm going to multiply the top and also I'll be multiplying the bottom by the conjugate. So instead of minus 3, it is now plus 3. Okay, just making sure you see that. Hopefully we move out of the glare here. Okay, now from here, I'm going to be using the property. And let me remind you of this specific property. That special property, a minus b times a plus b is equal to the first term squared minus the second term squared. That's why multiplying by the conjugate is going to simplify our answer and make things nice and easy. So we're going to be using that. This is my a, this is my b, a, b. So we're using this property right here. We talked about this in the first semester. So what this is going to give me, I'm going to put my equal sign. That's going to give me this squared, a squared, minus b squared, all over. And then this right here doesn't really simplify. I'm just going to go ahead and write it out. That's just going to be x minus 7 times the square root of x plus 2 plus 3. So far I got this. Now, up to this point, I'm going to be simplifying the top. What I'm going to do next is simplify this. This right here, 3 squared, is going to become a 9. The bottom I'm just going to leave. So right here, when I square something that has a square root, these basically cancel. This square cancels out the root. What we're going to be left over with is just the x plus 2. Let me write out that step right over here. Continue to use blue. So what I'm left over with on top is x plus 2 minus 9, because the root went away and the 3 squared became 9, all over, and I'm just going to go ahead and rewrite my denominator. All right, we have this. Now let's go ahead and simplify. So 2 minus 9 is minus 7, all over x minus 7 times the conjugate that we multiplied by. Good, so we have this long thing, but now I see that my problem, the fact that I couldn't plug in by 7, is now going to be solved because these end up canceling out. Once you cancel those out, this becomes 1 all over x plus 2 plus 3. Now I am able to plug in my 7 that I could not plug in before because I multiply the top and bottom by the conjugate. This is a simplification technique. Now let's go ahead and plug in 7 and find out the limit. So now that I'm going to plug in 7, I'm going to get 1 all over, it's going to be 7 plus 2, square root of, plus 3. I know that 7 plus 2 is 9. The square root of 9 is 3. So it's 1 all over 3 plus 3, which is finally my answer, is that the limit as x approaches 7 of this function is 1 over 6. And we are basically done. That is number 1. The next problem that we're going to be doing is number 3. Okay, so number 3 is the one that has a fraction in it. We're going to be having to add fractions together in order to do this problem. Okay, so the first thing I want to note is that, and again I apologize for the glare that you are seeing, but the first thing that I want to note is that I cannot plug in 2 right here because 2 minus 2 gives me 0 in the denominator position. I cannot divide by 0, so that's a problem. So what I'm going to do, and I'm going to go ahead and write my next step right here so that the glare is not in the way. So what I'm going to do is I'm going to use my technique of adding fractions together. Hopefully, if I do that, I end up with something that can cancel by using the flipping and multiply rule, which you might see. Let's see if that ends up being the case. So here's my first step. I'm going to try to combine this into one fraction. So what I'm going to do is put this 2 over 1. Put the 2 over 1. I put it over 1. After I put this over 1, in order to have a denominator of x, what I'm going to do is multiply the top and bottom of this fraction by x. Let me write out what that looks like here. So then that gives me x plus 2 divided by x minus 2x all over x, all divided by x minus 2. My next step is going to go down here. Okay, because my denominators are now the same, I can go ahead and add up or combine my numerators. So then that's going to give me, and this is going to be my new step, it's going to give me x plus 2 minus 2x divided by x, and it's all divided by x minus 2. So again, this is separate so that it doesn't look smashed together. These are separate steps. Okay. Now, to simplify this, I'm going to be moving up over here, okay? So x minus 2x, that's going to give me negative x, and then we're going to have plus 2. Negative x plus 2, all divided by x, all divided by x minus 2. Now this next step is a little bit tricky. I'm going to go ahead and use my flip and multiply rule actually first, and then I'll show you that tricky thing. Let me put this over 1, and then we're going to do the flip and multiply rule. The top stays the same, so it's going to be negative x plus 2 all over x times, and we're going to flip this 1 over x minus 2. So here's where I'm at, and this is where the tricky part comes in. These two almost look the same, but they are not. What I'm going to do, I'm going to force these two to look the same. How I'm going to do that is by factoring out this negative right here out. If I take out this negative right here, if I take out a negative 1, that's going to give me negative 1 parentheses. The x now becomes positive, but because I removed the negative 1, this is going to become negative 2. All I did is I factored out a negative 1 from here. Because if I were to distribute this negative 1 back in, you would get this original again. So I factored out a negative 1. Once I do that, x minus 2 and x minus 2, they end up canceling. These cancel. Now what I'm left over with on top is negative 1 times 1, and at the bottom we just have x. So negative 1 times 1 is just negative 1 all over x. Basically now we are ready to plug in the forbidden number, which was 2. Now we plug in 2, so now basically our limit is just negative 1/2. And that's the end of this problem. So yes, most of this was just combining fractions, but then there was that last little tricky step, which was factoring out a negative 1 so that we could cancel out tops and bottoms of a fraction. So that was the tricky part of this problem. Okay, now let's move on to problem number 5. This problem number 5 is another conjugate problem. We're going to be multiplying top and bottom by the conjugate and seeing what we end up with. So in this problem, I'm going to try my best to write below the glare that you see on the board. I'm going to try my best to keep my steps much more organized to the best of my ability. So here we are, number 5. Because I already reviewed with you the conjugate technique, you know that in this problem I have to multiply the top and bottom by the conjugate of the numerator. I'm going to multiply the top by the conjugate, which is 9 plus x. The conjugate means that the sign right here changes. This sign right here does not change. Alright, and multiply top and bottom by the conjugate. Now I'm going to be using the a minus b times a plus b rule. Remember, let me remind you again actually. That's going to give me a squared minus b squared. So basically it's this squared minus 3 squared. That's what it's going to give me. because that is that special rule that we should know. So then here we go. Let's go ahead and write what this means. So then that gives me minus my 3 squared all over x times. So now we have this, and then we're going to go ahead and simplify. So the square gets rid of the square root, that cancels, and I just have 9 plus x minus 3 squared, basically that's minus 9, all over x times that conjugate. Nine minus 9 becomes 0. We're left over basically with x all over x and that conjugate. The x from here and the x from here will cancel. When I cancel, I'm left over with 1 on top and that conjugate portion in the bottom. Now that I got rid of that x in the bottom, I am now able to plug in 0 now to this simplified form. Let's go ahead and plug in 0 because that's what we're looking for. Then we got 9 plus 0 plus 3. 9 plus 0 is just 9. The square root of 9 is 3. Is this a coincidence? But 3 plus 3 just gives me 6. I'm not sure if that was the same solution as the first problem, but very similar. That is how you do number 5. So I did these 3 problems with you. I'm actually going to try to maybe leave it to some class time if you still have some questions on the other problems, because this video is already long as is. All right, thank you. See you then.